All right, so 5.2, multiplying polynomial expressions. So continue with this idea of multiplying them together. Now we're going to move past just monomials, but add in binomials with binomials and binomials with polynomials. So our essential question, how do you multiply binomials and polynomials? So algebra tiles kind of move past. Some of you guys have said you didn't like those, so I'm just going to go into showing you the steps of it. If you want to show algebra tiles, ask me in class and I'll show you that as well. So we have x times x, which is x squared, x times negative 2, which is a negative 2x, 1 times x is x, and then 1 times negative 2 is a negative 2. Combine our like terms, so we have those two terms right there. So we get x squared minus x minus 2. So the product of x plus 1 and x minus 2 in simplest form is x squared minus x minus 2. Okay, so using distributive property, so just continuing that idea, distribute each term, so x gets distributed into the x, that gives us x squared, x into the 2, that gives us 2x, 5 into the x, that's 5x, and 5 into the 2, which is 10. Combine our like terms, and we get x squared plus 7x plus 10. Continuing, distribute here, we get 2x times x this time, which is a 2x squared. 2x times 3 is 6x. 4 times x is 4x. And 4 times 3 is 12. Again, combining like terms, and we get 2x squared plus 10x plus 12. Going over here, just because we have an x squared doesn't change the process. We're still going to distribute. X squared times x now gives us an x cubed because we add. Our exponent's 2 plus 1 is 3. Distribute there, we get 2x squared. Now we distribute our 3, and we get 3x and 6. Now, as you can see there are no like terms, so then there's nothing to do with that one. It's in standard form. Our exponents go 3, 2, 1, 0, so everything's good. We don't have to do anything there. Now on this number 5 here, I'm going to show you another method to its area model. It's similar to, it comes from the idea of tiles as well. So what we have is we have our 3x squared minus 2x, and then our x plus 5. And so like your multiplication charts from elementary school where they match up, you multiply those together. So we get 3x squared and x multiplied together to give us 3x cubed. 3x squared and 5 multiplied together to give us 15x squared. Negative 2x and x gives us a negative 2x squared. And negative 2x and 5 give us a negative 10x. And then generally your like terms are on the diagonal. So that gives us 3x cubed, negative 2x squared, and 15x squared is a 13x squared, and then negative 10x. All right, multiplying polynomials now. So I have a binomial times a trinomial, but distribution still works. That's the beauty of that, not learning some other type of trick, is we can now just distribute. So x times x squared is x cubed. X times negative 5x is a negative 5x squared. And then x times 4 is 4. So we just have one more term we're distributing to, but the process is still the same. Once the x has been distributed all three, we now take our 2 and distribute. So we get 2x squared minus 10x plus 8. Now we combine our like terms. I only have the x cubed, so that gets written down. I have an x squared and x squared. It's a negative 3x squared. This should be a 4x here. And I have a 4x and then negative 10x. That gives us negative 6x. And then just my plus 8 at the end. There are no like terms. That's in standard form, so we're good. Same thing on 7. So distribute 3x is going to go to all of these. So I get a negative 6. 3 times negative 2, and then we multiply our x's together, gives us x cubed. 3x times 5x is 15x squared. And then 3x times negative 6 is a negative 18x. Now, some students like to line them up as they do the problem. That's fine as well. It's kind of like our vertical method. So negative 4 times negative 2 is 8, and then we get x squared, so that's a positive 8x squared. And then what they'll do is they'll write it right under the other x squared. And then negative 4 times 5 is a negative 20x. And then negative 4 times negative 6 is a positive 24. And then what they do is they add those straight down. Everything's lined up, so we're good. That gives us 23x squared minus 38x plus 24. Whatever method you prefer is good with me, as long as we're getting the same solutions there at the end. So reflection, to answer this question: can the distributive property be used to multiply two trinomials? So we've done a binomial and a trinomial. Can we do trinomial tests multiplied to another trinomial? All right, Oric has designed a rectangular mural that measures 20 feet in width and 30 feet in length. Laura has also designed a rectangular mural, but it measures x feet shorter on each side. When x equals 6, what is the area of Laurel's mural? So Oric has a mural that's 20 by 30. And then we have Laura's, which is x feet shorter on each side. So that's going to be shorter, so we're going to minus that amount. And then minus that amount. So then to find the area, remember area is length times width. So we're going to get 20 minus x times 30 minus x. And there's two ways you can do it. At this point, you can substitute the x in. So 6 goes in for x. And then we simplify, so we get 14 times 24. Which when we multiply that out, gives us 336. The other way is you can take and multiply that out. So 20 times 30 is 600. Then we get minus 20x, minus 30x, and then plus x squared. So then we get 600 minus 50x plus x squared. Substitute our 6 in still, so we get 600 minus 50 times 6 plus 6 squared, which still gives us 336. In this case, remember, it is feet squared. All right, your turn. So several problems here for you to practice. And we'll go over calling a couple people to share out, and we'll go over once you come back into class. Then you have your quizzes, and our essential question is, how do you multiply binomials and polynomials? What is the one key term that allows us to do this?